Welcome student. Today we studied measurement of length. We know that length is one fundamental quantity and meter is a unit of length. Before 1960 we cannot study how this standard can be determined. But in 1960 meter can be based on wavelength of orange red light emitted by atom krypton. But after 1983, the more precise measurement of meter can be developed. And here we can determine meter is the length of path traveled by light in vacuum during a time interval of 1 upon 299,792,458 second. For that, it can be possible only when the speed of light in vacuum can be expressed that 299,792,458 meter per second. For that we can determine here speed of light is nearly equal to 2.99 into 10 raised to 8 meter per second, or simply called as 3 into 10 raised to 8 meter per second. This meter can be determined as the length of path traveled by light in vacuum during a time interval of 1 upon 2.99 into 10 raised to 8 second. Okay, here some typical measurements of length can be determined in table number 1.2. Now we can determine measurement of large distance. We know that physics have number of physical quantities and these quantities may be small or may be large. Now we can determine here measurement of large distances. Large distances means some distances like as such distances like as planet, distance from planet from the earth, distance of star from the earth. These distances are very large distance, therefore we can't measure directly with meter scale. For determination of this distance we determine one method. That method is called as parallax method. Parallax method is the apparent change in position of object due to the change in position of observer. For that we have one simple experiment to understood this parallax method, that is hold your hand in front of you and look at it with your left eye closed and again with your right eyes closed. You feel that your hand appear to move against the background. We cannot change the position of hand, but we feel the change of position of the background. Because of what? We change the seeing position, that is we change the position of eyes. One time we see this hand with left eyes and one time we see this hand in right eyes. This effect is called as parallax effect. We simply studied this parallax effect by figure. This figure shows that this is the two position of eyes. E1 and E2 are the two position of eyes and P is the position of object. Then this OP is the distance between object, and here we get the due to this position, changing position of eyes, we have to determine this distance become changes, and therefore we have one angle can be determined, that is angle theta. This angle theta is called as parallax angle. Like as a plane angle, we can determine this parallax angle. The measuring of parallax angle between the eyes E1 E2, we can determine the distance of object from us, that is OP is equal to E1 by E2 upon theta, or angle theta is equal to E1 by E2 upon OP. This manner, using this manner, we can determine measurement of large distance. But when we can distance of planet from Earth, that are very large distance, we can't use this two eyes method, because two eyes method can be not possible to measure the distance of planet. For that, we consider two positions on the surface of Earth which are separated by straight line. Here in this figure, we have studied two positions A and B are separated by distance B. This B distance is a straight distance between this A and B. S is the position of planet, and this can be determined by two position on earth from A and B. Therefore, this triangle ASB, this triangle made angle theta, this angle is called as parallax angle. This parallax angle can be determined by this ASB, from triangle ASB. Here we can determine this angle is very far away. Suppose we have this planet is very far away. The distance of planet from the earth is very large. Therefore, theta is very small. Consider the AB is a arc of length B of the circle, and theta is the radius. For the plane angle, we can determine arc upon radius. Using this relation, AB is considered as one arc and theta is the uh, parallax angle, that is plane angle, and D is its radius. Then we have theta is equal to AB upon D, and D is equal to B upon theta, where D is the distance of planet from Earth. Using this distance, we can determine distance of planets from any planet from Earth. Okay, here we have this distance of planets or stars. It is very large distance. For measuring this large distance, we have different units can be used. That is one unit, that is astronomical unit. The astronomical unit is equal to this unit expressed in meter, and this unit is equal to 1.496 into 10 raised to 11 meter. This distance means the mean distance between center of earth and center of sun. That is, the astronomical distance is the distance between sun and earth. Okay, then we can determine another unit, that is light year. We studied that a star can be far away from sun, far away from earth, that is different light year. That is what is meant by light year. Light year is a distance traveled by light in 1 year, and 1 light year is equal to 9.46 into 10 raised to 15 meter. Then another unit also used, that is parsec. One parsec is means that it is a distance where one angstrom unit angle sustained at angle 1 second of arc, that is called as 1 parsec, and 1 parsec can be determined as 3.06 into 10 raised to 16 meter, or 3.26 into 26 light years. That are the major distance. That is large distance can be determined using this unit. but there are very small quantities like as the size of electron, the charge on electron. This is very small quantity. Wavelength of light, that is very small quantity, and for that we can determine also small quantity expressed in different unit, that is Fermi. Fermi is a unit of determination of small quantity. Fermi also written as 1 femtometer, that is 1 Fermi is equal to 10 raised to minus 15 meter, and another unit is equal to angstrom. 1 angstrom is equal to 10 raised to minus 10 meter. That are the measurement of small distance and larger distance. Okay, we studied here measurement of length. Okay.